Review of work and energy. Work is done on an object. So a couple things going on here. We have the definition of work here. It's done on an object only when an external force moves the object to another position. So here's our object. Here's an external force, and it's moving a distance parallel to the force. That's the key. The force has to be parallel, or if you want to use the word anti-parallel, and anti-parallel means this direction. In the same line, but in the opposite direction of the motion. So work will be positive when the object acted on by the force moves in the same direction as the force. It will be negative when it moves in the opposite direction of the force. And it will be zero if it doesn't move at all, or if the force is perpendicular to the motion. So if we have a force pushing down on this object, but it's moving in this direction, this force here does zero work. Energy is a property of nature, and it's very hard to define, but it appears in different forms and can be changed from one form to another. The amount of energy of an object can be increased or decreased, frankly that's how you change things, by work being done on it. So we have our work-energy equation. We have an initial energy plus work is equal to final energy. Positive work will add energy to an object. Negative work removes energy from an object. And work and energy have the same units, joules. The first energy we dealt with was kinetic energy. That is the energy of motion. It has to be moving. So kinetic energy, abbreviated KE, is equal to 1/2 times the mass of the object times the speed squared. Potential energy is the stored energy of an object due to its position. Gravitational potential energy is the stored energy of an object due to its height above the ground. It's a specific kind of potential energy. It is abbreviated GPE, and the equation for it is mass times g, which is the acceleration due to gravity, times the height above the ground. Total mechanical energy of an object is the sum of its kinetic energy and its gravitational potential energy. As you go through physics, you will find out there are different types of energy that contribute to this, but for now we're going to stick with kinetic energy plus gravitational potential energy. Energy is a conserved property of nature. What does that mean? It means it can be neither created or destroyed. However, it can be transformed or changed from one form to another, like gravitational potential energy to kinetic energy, or the reverse. An object will always have the same amount of energy unless it is affected by outside forces that add or remove energy by the work done on the object. When there is no outside force doing work on the object, work equals zero, and this equation here, the initial energy plus work equals final energy, just becomes initial energy equals final energy. For the two energies we're working with, which is kinetic energy and gravitational potential energy, they sum up to form total mechanical energy. And we say that it is conserved when an object is not affected by any outside force. So here's our base equation. We have the initial status over here, and then the final over here. What's interesting is we don't care about anything happens in between. We just want the beginning and the end. We then substitute in our equations for kinetic energy and gravitational potential energy. And note the subscripts. This tells us that it's the initial energy, the I there, and this F tells us that it's the final energy. You can apply conservation of energy using a table to find the height or speed of an object. So let's say you have an object that can be in three different positions, A, B, and C. You can calculate the GPE by knowing H and multiplying it by mg, and that gives you your gravitational potential energy. You can calculate kinetic energy down here by knowing the velocity and also the mass of the object, and then you take that velocity, mass, and the factor 1/2, and you have your kinetic energy. Then you can find your total mechanical energy, which will be your kinetic energy plus the gravitational potential energy. So we add this term here, GPE plus KE, and you can see how here comes the GPE over here. Here comes the KE. You add them together and you get total mechanical energy.